Okay, so now I'm gonna be solving this problem. 2661. First, completely painted row or column. Let me read that problem. I have not read it before. So here I should go paint 1, then I should go paint 3 matrix, and then I should go paint 4, and then now gonna be row, and so like 2. So row gonna be painted and one column gonna be painted simultaneously at index 2. Let's check this one. So 2, 8. Can it be like repeating? Okay, all are unique. 2, 8, 7, then 7, then 4. So the index at index 3, it can be painted this 2, 4, 7 middle column. So the constraints are pretty, I would say, pretty large. And I can feel some binary search problem here. The only problem is that it's incrementally. I can first save the indexes of the values. So let's say I'm gonna have a hash map, and the value gonna be at the specific index, and then I'm gonna have a row and columns, painted painted squares, number of painted squares in every row, in every column, and as soon as like either in row or in column painted squares so every time I paint the square it's gonna be like the row that's gonna have that square. I'm gonna update number of painted squares in the column, gonna update it. So I'm gonna have hash map, and then integer, and int with the indexes, and then gonna be map, gonna be new hash map, and then for and I equals, so int rows equal r length, and int columns equal r0 length, and for and I equal 0 I less than rows I plus plus, and then map put ri. Okay, so also gonna be the same for int j equals 0, j less than calls j plus plus, and then map that put, and then rij, and then inside I wanna put the index new int ij. So, and then I'm gonna have I'm gonna need int columns equals new int calls, and then int rows equals new int rows, and then I need to go iteratively and then start coloring, and I'll update. So for int I equals mat, so mat, and then rows mat ij. So for int I equals 0, I less than r length, I plus plus, and then I'm gonna do map.get, so the int player gonna be map.get ri, and then go column, so the column index gonna be columns p1 plus plus if columns pi gonna be equals rows, I'm gonna be return I, and then the rows gonna be also updated p0 plus plus, and then if rows and here gonna be equals if p0 gonna be, if rows counted p0 gonna be equals columns, then I'm gonna have return I, and then in the end I will return -1, but it will never happen because ri gonna have all for like all m by n, so r length m by n. Okay, so let me quickly review what I have right now, if it's right, not right. So I go through the given matrix, and I save the mapping between the value at matrix and the index, like index of row and the index of column. Then I'm gonna have this column count and rows count, and like this is gonna be number of colored columns. Another number of columns count gonna have like in a column under I how many rows are colored, and then rows in row I how many as soon as either of those become colored, as soon as either of those becomes colored, I will return the index, otherwise I will return -1. Okay, that's it. Let's check what they have here. Okay, similar, but I wonder why. Okay, let's check what the time. So I thought it is in 10 minutes. So the time complexity here, let's check code. What is better here? So solutions. This is much better. Why? So here water also goes through the whole it's like what? It's because of savings in a separate arrays instead of saving it in a hash map. I guess so. Okay, let's if I change my code here, code, not this one, this one. Let me change it. Will it be better? So I'll have the int map row called new int. This one gonna have rows by calls +1, and then gonna be int map call, gonna be new int rows by calls +1. I can even save like this, like 2, and then have map, and then map map I map I j equals new int. Okay, and then map like that. If I run it, to better memory, but not that good. If I'm gonna have the separate map call, and then I'm gonna have also map row, new int rows calls this one. Map ij, map row, map call j. Okay, so map row, and then row pi, and then pj gonna be map call ri pi pj, and here pi pi. Will be oh, it's much faster. That's interesting. Why it gives such a big optimization instead of like 2D array, just having two 1D arrays. Okay, this seems like inverted solution. Okay, I'm gonna end up recording. I think it's a success, or I mean pass. Thank you for watching.